Hi everyone, I am Dinesh from CS third year, Asram University. Welcome to my channel. I am going to share with you about vehicle insurance project based on data warehouse and data mining techniques. We are diving into something super interesting and very relevant data-driven world. We will be exploring how large amount of vehicles and customers' data can be stored and processed and analyzed to make smart predictions like whether a person is likely to buy insurance or not. This video will take you through what a data warehouse and is why it is useful for this kind of analysis, how data mining helps us extract patterns from that warehouse. And finally, we will go through a complete Python project and that predicts vehicle incidents purchase behavior based on customer features using machine learning. So if you are data enthusiast, a student working on projects, or just curious about how data is related like insurance, you are in the right place. Make sure to like this video if you are helpful. All right, let's start the let's start the project. Now I'm going to share the code. This the code based on this project. Here I used some essential Python libraries like Pandas for data handling. Pandas here we are using Pandas for data handling, Seaborn and Metaplot for visualization and Scikit-learn for machine learning, and then two data sets, one for training and one for testing. Useful PD-read CSV. These files contain customer information like age, gender, driving license, status, vehicle damage, and whether or not they bought insurance. Next, we have training and data set of gender. This will convert the gender value from text to number, like female 0 to male becomes 1 and female 0. Then I use one hot encoding to handle categorical variables like vehicle ages, policy sales, channel, and I rename the vehicle age columns for clarity and make sure everything is in an integer format. Finally, I drop the ID column since it is not useful for predictions. I have splitted the train and test data. I separated the target variable called response, which tells us customer bought insurance or not. Using training test split, I divide the dataset into training and testing set. Here I have divided the training and test by using split. So we can evaluate the model performance later. Here we have used the models like random forest with hyperparameter tuning. Here you can see that random forest name imported from the Scikit-learn model, randomized search CV. From this, we can do training and testing in this model by using random forest. I use randomized recipe to automatically turn the hyperparameters like maximum depth, minimum samples per leaf and split, and number of trees. This helps us model perform better without manual guessing the best values. Next, we have model training and evaluation. Here we will get the output which we have done from the random forest. It will give us the classification report based on the prediction value and score and the area under the curve also. Here we can see the area under the curve. Here we got the output for random forest. This is a label class 0 and label class 1. 0 means female, 1 means male. Here we got the values of precision, recall, F1 score, support. For label class 0, precision is 0.92, recall 0.66, F1 score 0.77, and support is 12157. Here label class 1 means male, 0.73 for precision, recall is 0.94, and FN score 0.82, and support 11755. Also, we have got the Markov average and weighted average accuracy. And finally, we got area under curve based on random forest. Here we got, you can see the value 0.855 we got for random forest. This is for every each 10 candidates, total 40 fits. Here we can also use logistic regression and gradient boosting classifier. These three are we have used the from Scikit-learn library. For all regression, we can see for label class 0, we have 0.96 precision, 0.59 recall, 0.73 FN score, and support value is 12,157. For label class 1, precision is 0.70, recall is 0.97, FN score is 0.81, and support we got 11,755. And for that logistic regression, the area under curve is 0.8393. For gradient boosting classifier, for this we got label class 0 is 0.91 for precision, recall is 0.67, FN score is 0.77, support is 12,157. For label class 1, precision is 0.73, recall is 0.93, FN score is 0.82, and support we got 11,755. For this area under curve is 0.85967. Now we are going to explain. Now we can go and explain. Finally, I have saved this trained random forest using pickle, so we can reuse it later without retraining. By using pickle, we can store and reuse it later. Now we are going to. Uh, we have built our first model using random forest with some basic evaluation. Now we are taking the step further using a balanced training dataset and visualization performance using ROC curve. Now we are going to see ROC curve. In this, we have seen some libraries used Pandas, Seaborn. First, I said for Pandas, we use it for data handling, and Seaborn used for the visualizations from machine learning. Now we can see the code here. Here we have used training and testing. We have taken PDRED, CSV, PDRED, CSV, and we have the content from previous one. Just like before, I started my importing libraries and recording, training and testing CSV files. I converted the gender 0 to 1 and apply the encoding for category features and rename convert columns related to vehicle age and damage and drops the unnecessary ID columns. Later, we have done preparing the data. I also define the target variable response and split the data into training and testing sets using train set split. I am using the same hyperparametric turning setup for this before we are used, but here the training data set has been balanced to ensure both class people who buy incidents and those who don't buy are fairly represented. What I'm saying going to say means here we are using balanced thing. So they can have both fairness. For maintaining fairness, I am using balanced classes. I am here I'm training the random forest model using randomized search CV, which help us automatically find the best combination of hypermetrics parameters. After training, I uses the classification report to check metrics like precision, recall, FN score, which tell us how the model is performing. See here, I have got the ROC curve for random forest. By using this, we can plot the graph by using a PLT. This import from the Scikit-learn library so that we can plot the graph. See here we can see the graph of ROC of vehicle incidents. Now I am going to explain training the random forest model. Build a real-time prediction system that takes input from user like their age, gender, driving history, and tell them whether they are likely to buy insurance or not. Here we can see we are taking the age. That means we are taking the age of a person and gender, and we are going to have asking them whether they have license or not. And taking the religion means which religion they belongs to, and if they have insurance or previously they have insurance or not. We are taking the input yes or no, and how old the vehicle is. I mean the age of the vehicle, and you are taking the number of days that particular person associated with the company, and what amount currently paying with the insurance if they have insurance, vehicle damage or not, and entering the coding of that particular region. Every region has some code. That code we should write here, and we have the code here. I mean, for age that should be between 18 and 100. This is the range for the age, and gender male M denoting M, and gender female F denoting female. D1 means S, Y indicate S, N indicates no. These are the components, and we are going in here. We are going to processing the input. That means it converts all the text-based values into the format that in order understanding. For instance, gender male M become 1, F becomes 0, vehicle damage Y becomes 1, N becomes no. Vehicle damage is mapped into two binary features if it is less than 1 year or more than 2 year. That means here taking the less than 1 year, more than 1 year. After that, if we are loading the training model, here we are loading the training model. Pickle.load. Pickle means we are storing and later we can use it. Here we are this is used for the showing the prediction results. What are the outputs that we got from the inputs? After processing the inputs, we'll got some outputs that are stored in here. We can see that outputs. If the prediction is 0, the output says you are not likely to buy vehicle insurance. If prediction is 1, the output says I think you will buy vehicle insurance. This is complete real-time application based on real customer inputs. I have taken here one example. Age is 20 and gender is male. The license is S. That means they have license. Which region belongs to means 28 means that code for that particular region. I mean, like example, Kadapa like that. Do you have previous insurance? Yes, they have previous insurance. How old your vehicle is? 4 years old. The person is by the vehicle 4 years completed. Number of days you have been associated with company, 387 days. What amount you are currently paying as insurance premium? 234 rupees. And vehicle damage is S. And the code for the channel for outer reaching to you, 124. That gives that they are saying that you are not likely to buy vehicle insurance. That means we got 0 as a prediction, means we are not likely to buy vehicle insurance. Already they have insurance. In this, we are going to go about sample from our original data set and see how trained model perform on multiple records at all once. That means multiple values will take at a time and process that multiple records at once. In this part, I'm going to say 10 rows from the main dataset using Pandas, read CSV with skew, pro, and n rows to limit the number of records. That means by using the n limits, we can have some limit. We will not take all the values. We have some limit. In that limit, we will take the values. This simulate a real world use case. Maybe you are building a dashboard where you want to make predictions for a few customers at a time. At a time, we can make some limit, a set of customers in this by using this. Here, like we process the data. That means I said before, converting the gender 0 to 0 or 1. That means male means female means 0, male means 1. And encoding the category values using get DUMINS. Rename some columns for consistency, convert all necessary for consistency. Drop the ID columns and the response columns since we are trying to predict it now. It's exactly the same processing pipeline we use for model training. In this, we are going to load the training model. That means I load the random forest model that we saved earlier using pickle. This allows us to reuse the model without retraining. Using of pickle is we no need to train it. We have all trained the data before, so now we can use it by using pickle. Super useful for production apps. Here we are going to print the run the model prediction on 10 records just processed, and we'll got the output based on 0 or 1 for each person of data. If it is 1, the model believes the person is likely to buy insurance. If 0, they are not probability not interested. Here we got the some output that means 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0. 0 means we know that the person is not likely to buy the insurance. And also we got 0. That means 3% not going to buy the insurance. And after that, 3 people are interested to buy the insurance. And after that, not again, 4 people are not interested. That means overall 10%. Some members only not likely to buy insurance, and 3% are likely to buy insurance. That means the 3% don't have the vehicle insurance, so they can buy the vehicle insurance. Based on this training model, we have got an output. Now I'm going to here for this from this code, we have data processing and cleaning, model building and training with random forest, logistic regression and gradient boosting, and real-time user predictions with interactive inputs, batch prediction using actual data. I walk through a beautiful Power BI dashboard built using the same vehicle insurance data we have been working on. So now I'm going to use a Power BI for visualization. By using Power BI, we can represent the diagram data into pictorial way. So that in pictorial way means pie chart, like pie chart, histogram, line diagram, etc. Now see here, first diagram we have pie chart. In this pie chart, we have male, female, and male. It shows that male are 61% and female are 38.93%. It tells us that male customer were more likely to respond for positive to insurance efforts. That means male are going to have some more interest over the insurance compared to than female. So that the male person is more. In this diagram, you can say that. And later we have the bar diagram. It says the policy sales channel versus responses. This chart shows the relationship between the sales channel and customer responses. It helps us to understand which channel we are more successful in convincing customer to purchase insurance. That means which channel is used for the convince the customer. Here we have the 2 channels. One is policy channel and another is response. Here we can see that response have the more percentage than policy. And sum of response are 29K. Here we can see the vintage was right. You can see the line graph. Line graph means you see here. In this, we have sum of vintage and sum of driving license. Based on these 2 comparison, we have the line graph. Sum of vintage denotes the dot, and sum of driving license denotes the blue color dot. Here we can see that it is not surprised that almost all responded had a valid license, something and essential for vehicle insurance. Now you can see the pie chart again. In this pie chart, you can see vehicle damage percentage. That means how much the vehicle is damaged. No means here we can have more percentage for no. No has no for more percentage. That means it indicates the vehicle damage is less compared to vehicle S. Here you can see table. This table indicates the sum of previous count. That means how many numbers have taken the insurance at all. 1 year, 2 years, like that. Totally we have 95,646. This is the Power BI. By using Power BI, we have established data into pictorial way. This is so useful for pictorial representation. And that's the end of our Power BI bonus analysis. It gives a great overview of user behavior and helps validate what we have learned from our machine learning model. Together, we have given a full stack view from data to prediction the pictorial way. If you found more helpful, make sure to like and share and subscribe to this channel. Drop a comment. Thank you.